we have here a k-list table that will help us in determining the index of our subgroup generated by mu sub 1 in the group of S sub 3. So we have here this k-list table, and we are going to use that as we determine later on the orders of our subgroup together with our S sub 3 that will be used in solving for the index of the said subgroup. Now, of course, our S sub 3 here is a set containing all the permutations on A sub 3, right? So we have here rho sub 0, rho sub 1, rho sub 2, mu sub 1, mu sub 2, mu sub 3. If you were not able to remember, or if you forget, these elements are permutations on a set with 3 elements. Okay, the rhos are actually the rotation, the mu's are actually the reflections against the perpendicular bisector of a side of a triangle in this case. Now, our mu's, or the subgroup generated by mu sub 1, okay, that is where our k-list table will come in right now. Let us list here all the elements pertaining to that. Of course, you will start with mu sub 1, right? Okay, so if we have here mu sub 1 operated to mu sub 1, our k-list table will give us mu sub 1, let's use here one here, mu sub 1 here, their intersection is rho sub 0. Okay, that would mean our second element is, or let me just use our first element here, so that would be our rho sub 0. That's the first element of our subgroup generated by mu sub 1. And then if we're going to operate our rho sub 0 against mu sub 1, the result is also mu sub 1. Now, if we're going to repeat the process, you will just be coming up with the same results: rho sub 0, mu sub 1, rho sub 0, mu sub 1. So this is actually the subgroup generated by mu sub 1. This is a subgroup because it contains our identity element here, rho sub 0, and that the inverse of our mu sub 1 is mu sub 1 itself. The same with rho sub 0 as rho sub 0 itself. So this is a subgroup. Now, if we talk about index of the subgroup generated by mu sub 1, let's just simply call this as our H. This would be our G in general form, because this is the formula in solving the index of H in G, or the index of the subgroup generated by mu sub 1 in S sub 3, indicated by this notation. This is the index of H in G. So this is actually just the ratio of the orders of our G, which is S sub 3, and the subgroup generated by mu sub 1. So index orders mean the number of elements. So there are 6 elements on S sub 3. We have rho sub 0, 1, 2, mu sub 1, 2, and 3, to be divided by the number of elements, or the order of our subgroup generated by mu sub 1. We have 1 and 2, 2. So the index of H in G, or specifically the index of the subgroup generated by mu sub 1 in S sub 3, is actually equal to 3. This is how we show the index of the said subgroup, but we started with identifying the number of elements on the said subgroup. Now, if you would like to connect this to our previous topic or our next topic, this is actually determining the number of cosets. So the index of H in G, or the index of the subgroup generated by mu sub 1 in group S sub 3, is telling us the number of cosets that we could have for the subgroup generated by mu sub 1 in S sub 3. Now this is true to both number of left cosets, there are 3, and number of right cosets, there are also 3. This is the reason, or this is the beauty of understanding the index of a certain subgroup to a given group, because it tells us the number of left and right cosets. Thank you very much for watching.